Hello everyone, I'm Leo. Today I will introduce the strengthening of the Kuroshio current by intensifying the tropical cyclones. Then, first I will introduce the Kuroshio current. Kuroshio current is a subtropical boundary section of the North Pacific ocean grid, and it will separate into several branches near the Japan. And today I will mainly focus on the mainstream here. And then its importance is that it will take in the warm water to the high latitude, to high latitude and influence the climate of this region. Then next I will introduce what is the potential vorticity. First, we need to know that what is vorticity. Vorticity is a vector to show the spin ability of the fluid, just like this one. The arrow point 4. Then the potential vorticity is a vector that absolute vorticity divided by the thickness of the fluid or water. Just like this formula, the F is for the Earth rotation. The is for the vorticity which caused by the Earth rotation, and the zeta is for the vorticity that caused by the wind and by the pressure of the current. And H is for the thickness of the fluid, just like we can imagine there is a fluid for this one, and the thickness is for here, and the arrow is for the potential vorticity. Then this is for the potential vorticity anomalous. In this picture, we can see the cyclone or the cyclonic. It is for the counterclockwise rotation, and we can use the right-hand rules that the four fingers point 4 is for the rotation direction. It is the counterclock, and my thumb point 4 is for the PV direction, just is for upward, and we can set the upward is for positive, and the downward is for negative. Then introduce what is the wind stress curl, and wind stress curl is combined by two parts: is wind stress and curl. And what is wind stress? Wind stress is a force of wind on the water surface. It is like this. Here is the sea surface, and the wind flow by, and the wind stress will be formed, and it will cause the current. And what is curl? Curl is a measure to describe the rotation of the fluid or air. It is similar for the potential. It is similar for vorticity, but it is a little difference. And it caused by the velocity difference. And in this picture, we can see an object floating on the string, and here will be in the middle of the string has the most velocity, and has lower. Here is the smaller velocity here. So there has a velocity difference. So it will cause the object to spin. It also can use the right-hand rule that the rotation direction here, and it will cause the curl to point out of the water, just like it will. Then this one will be the clockwise rotation, and this one is B. Since there is no velocity difference, so there is no curl. Just like this picture. It is out of water and it's going to water. And we can combine these two parts together. Wind stress curl describe the changes in wind stress that creates rotational motion in the water. We can imagine that we change the object into a fluid, and we can see that is the wind stress curl. And then I will tell the results for this research first to guide you to know what is the paper doing. First, we can since the there is a the paper shows that the tropical cyclones will cause the variation of potential vorticity, and since there is a climate warning and the tropical cyclones are being stronger and more frequencies, and so there must be some positive feedback between this. Then the wind stress curl decrease will cause the Kuroshio current decelerated, and a positive PV anomaly will cause the Kuroshio current as accelerate. Then we can then we talk the relation between the tropical cyclone and the ADs. In this picture, we'll average the variation of the energy changing rate in 15 days after a tropical cyclone forms. And we can see in this picture, the blue line is for the cyclonic eddies, and the orange line is for the anticyclonic eddies. Here has the significant. Here is a large variation for the energy changing. So we can think that the tropical cyclone can buff the cyclonic eddies, and it also will nerf the anticyclonic eddies. Then here is about the wind stress curl to affect the Kuroshio current. First, then here the view in this four picture, the data in this four picture is have been normalization. So it can be more easily to guide what is the relative between the transport and the year, and the y-axis is for the relative, and the x-axis is for the year, and we can the view we can compare with picture B and picture C. Can know that upstream has more transport decrease than the downstreams. That's like the section 3 and section 9. The slope has the more decrease than the section 9. And we can also compare the picture C and picture E. The wind stress decrease more than the transports, so that there must be another reason to offset the deceleration. Then next, it is about the PV anomalies to affect the Kuroshio current. And in this picture, we can see there is a orange regions that that have a positive PV anomalies, and there is a light blue regions that it is. Okay. there is a light blue regions that is caused by the anticyclonic, and it is a negative PV anomaly. So net positive PV anomaly will push the Kuroshio current toward the east, and there must have a northward accelerates to balance the westward acceleration, and it is the Kuroshio current, while the Kuroshio current will be accelerate. It is the main reason about this, and this is the reference. And thank you, everyone.